Hi and welcome to John's Maths book. In this video, I'm going to be showing you how to calculate the inverse of a 3 by 3 matrix. If you like the video, then don't forget to hit the like button, and I'd be delighted if you could subscribe to the channel. Without further ado, let's go over to the whiteboard. So I've written matrix A, which is a 3 by 3 matrix at the top left-hand side of the board. So we're going to try and find its inverse. Now, its inverse is its adjoint divided by its determinant. Now, when we're trying to find the inverse of a 3 by 3 matrix, the determinant of that matrix cannot be 0. And we should also note that when we multiply the inverse of the matrix A by A, it must equal the matrix multiplied by the inverse because it's non-commutative, and all that must equal the identity matrix. So our goal here is first to find the determinant of A and then its adjoint. So let's begin with the determinant. To find the determinant of matrix A, we take each element in the first row and we eliminate its rows and columns. We then are left with a 2 by 2 matrix of which we need to find its determinant. Once we've found its determinant, we multiply it by its associated first row element. So let's start with element 0 in the top row, and we eliminate its column and its associated row, and we find that we're left with a 2 by 2 matrix here. So we multiply 0 by the determinant of the remaining 2 by 2 matrix. That's minus 4, 4, minus 2, 1. And then for the next element, minus 3. We eliminate its rows and columns, and we're left with a 2 by 2 matrix. It consists of these circled numbers. So we subtract, minus 3 times minus 3, and then we multiply that by the determinant of the remaining matrix. And finally, we take the element minus 2, eliminate its rows and columns, and we're left with this 2 by 2 matrix. So we multiply minus 2 by the determinant of that 2 by 2. So it's 1 minus 4 minus 3, 4. So for the first determinant, it's 0 because it's multiplied by 0. Then we have a minus 3 times a minus 3, so it's a plus 3 multiplied by the determinant of this matrix here, so this 2 by 2. The determinant is 1 times 1 minus 3 times minus 2. This 1 times 1 is 1, minus, and then minus 3 times minus 2 is 6. And then plus minus 2 multiplied by the determinant of this matrix here. So it's 1 times 4 is 4, minus 4 times 3 is 12. So minus 4 times minus 3 is 12, so it's minus 12. That works out to be, so 1 minus 6 is minus 5 times 3 is minus 15. And we have a minus 2 times a minus 8. So that's plus 16 equals 1. So the determinant of A is equal to 1. So let's add that into the top right hand corner here. So the determinant of A is 1. Now we've found the determinant of A, we need to find the adjoint of A. Now, to find the adjoint, we have to go through a number of steps. So we need to replace first the elements of matrix A with the determinant of its minor. So the way we do that is we take each element. So for example, if we take the first element in row 1, column 1, which is 0, and we eliminate its column and its row, we find its minor here. And of that, we take its determinant. We then take the determinant and replace the element in row 1, column 1 with that value. So let's start with -4, 4, -2, and 1. And then if we look at the second element, which is -3, we eliminate its rows and columns, and we have a matrix of 1, -3, -2, 1. And then on the top row again, we have element -2. Eliminating its rows and columns, we get 1, -3, -4, and 4. So now we go ahead and find the determinants of these matrices. So the first determinant is this number minus this number. Sorry, this number times this number minus this number times this number. So we have -4, and -8 becomes +8. That equals 4. So we have 1 times 1 minus -2 times -3. That is 1 minus 6, which is -5. And we have 1 times 4, which is 4, minus -3 times -4 is 12. So that's 12. So we can start building our new matrix here. So in the top row we have 4, -5, and -8. So next we need to work on row 2 of matrix A and eliminate rows and columns of each of the elements. So if we start with row 2, column 1, and eliminate the rows and columns associated with the element 1, we're left with -3, 4, -2, and 1. And then element -4, which is in the middle, we're left with 0, -2, -3, and 1. And then finally, row 2, column 3, which is -2. We eliminate its rows and columns, and we have 0, -3, -3, and 4. So now if we calculate these determinants, so we have -3 minus -8, so that's +8. That equals 5. And we have 0 times 1 is 0, -6, which is -6. And then we have 0 times 4, which is 0, and that's -3 times -3, so that's -9. That equals -9. So if we plug these into the new matrix, we have 5, -6, and -9. Last but not least, we look at the third row of matrix A. Eliminate the rows and columns associated with each of the elements. So starting with column 1, row 3, we can eliminate column 1, row 3, and we're left with -3, -4, -2, -2, and column 2, row 3, we're left with 0, 1, -2, -2, and row 3, column 3, eliminating those, we get 0, -3, 1, and 4. So calculating these determinants, we have -3 times -2, which is 6, and then -4 times -2, which that's 6 minus 8, which is -2. So we can put this value in here, -2. 0 times -2 is 0, and then we have -2, 0, minus -2 becomes a plus. Minus times -2 equals 2. Add 2 in here, and we have 0 times 4 is 0, minus, and then 1 times -3, that becomes a +3, so -3, that equals 3. So I've cleared the board to make a little bit more room, and I've written the matrix of minors below matrix A, and next to it I've put a matrix of plus and minus signs. Now the matrix of minors, some of the elements need to have their signs changed in accordance with the matrix to the right. So let's just do that. So 4 remains the same. -5 and a minus, that becomes a +5. -8 and a plus, that stays as -8. 5 and a minus becomes -5. -6 and a plus is -6. -9 and a minus is a 9. -2 and a plus is -2. 2 and a minus, that becomes -2. And 3 and a plus stays as 3. This now gives us the matrix of cofactors. So now the final step in finding the adjoint of A is to transpose the matrix of cofactors. So we take each column, so we take column 1 and we make it the first row in the adjoint. That becomes 4 minus 5 minus 2. We take the second column and we make it the second row. So it's 5 minus 6 minus 2. And we take the third column and it becomes the third row. So it's -8, 9, and 3. So I'll write the adjoint into the matrix in the top right. So we have 4, 5, -8, -5, -6, 9, -2, -2, and 3. So now that's all that's left to be done to find the inverse is to divide the adjoint by the determinant of A. So A inverse is equal to 1 divided by the determinant of A multiplied by the adjoint of A. Now we know that the determinant of A is 1, so 1 divided by 1 is equal to 1 multiplied by the adjoint 4, 5, -8, -5, -6, 9, -2, -2, and 3. The inverse of matrix A is 4, 5, -8, -5, -6, 9, -2, -2, and 3. So that completes this video on finding the inverse of a 3 by 3 matrix. That's it for now, and I'll see you next time.